Okay, AP Chemistry class. This is a lesson for Tuesday, September the 17th, and for that evening, and it's on dimensional analysis. We're going to be talking about this in class tomorrow. Okay, so what is dimensional analysis? Dimensional analysis is a method of solving chemistry problems by arranging the units of measurement so they cancel to give the desired answer. So the easiest way to understand that is just to look at some examples and see how this works. So we're going to take a very simple example of how many inches in 1 yard. So in order to do dimensional analysis, you must have conversions. So you have to have a conversion that gets you from inches to yards or from yards to inches. So if we don't have that directly, we might need to have more than one conversion. So the conversions we're going to use is ones that I think you all know already, that there's 12 inches in 1 foot and that there's 3 feet in 1 yard. Now those are called conversion factors. You can create 2 ratios from each conversion factor. There's 12 inches for every 1 foot, that's the 12 inches over 1 foot, or there's 1 foot for every 12 inches. Now you can do that. You can state it in either way because you do have a unit of measurement attached to the number. So those are both valid statements. There's 12 inches for every 1 foot, or there's 1 foot for every 12 inches. Those are both valid statements. Those are both logical statements. Now the same thing with 3 feet and 1 yard. So there's 1 yard for every 3 feet, or there's 3 feet for every 1 yard. Those are both valid statements. The reason you do it both ways is you don't know which one of these you're going to need to solve your problem. So let's go on to the example and you'll see how this works. Okay, so how many inches in 1 yard? So you begin by writing an equation and you place what the problem is trying to find way over on the far right. And I would do that as far on the right-hand side of the paper as you can. And then you place what you're given to start with. In this case, it would be 1 yard. So we're trying to find inches, and we're given 1 yard to start with. You place that on the far left. What you're doing is you're creating an equation, and you're going to fit those conversion ratios in between to lead you from the left side over to the right side. And so you place multiplications of the conversion factors to find the answer. So the problem wants you to find some number of inches, and it gives you 1 yard to start with. So it looks like what you see down there on the bottom. You start with 1 yard over on the left, and over on the right, it's some number of inches that you want to end up with for your final answer. So you choose the conversion ratios so that yards cancel out because you don't want yards in your final answer, and inches appears on the top at the end of the problem because you want inches to appear in your final answer. So you have these 4 conversion factors to choose from. So there's only one of them that makes yards cancel out. That's the one with yards on the bottom. So you start off with 1 yard times 3 feet divided by 1 yard. And you see that you have yards on the top and yards on the bottom. So those are going to cancel out. And then you want to end up with inches. So you choose the one. There's only one of the 4 that has this, that has inches on the top. And that's the one that says 12 inches for every 1 foot. So let's look at this. So this ratio, the one on the left, makes yards, YD, cancel out. 1 yard and there's yard on the bottom. The one on the right makes inches appear on the top in the final answer. And you'll notice that the feet cancels out in the middle of the problem. You have feet on top and feet on bottom. So if you look down at the bottom, how many inches in 1 yard? Well, yards canceled out, feet canceled out. The only thing left remaining is inches in the very last conversion ratio. And so that's going to be the unit of measure in your final answer. So since the units canceled out properly, then that means that the numbers will work out to give you the final answer. So the way you do this is you say 1 times 3 times 12 divided by whatever's on the bottom, which is just 1. So 1 divided by 1 divided by 1. But 1 times 3 times 12 equals 36. And so the unit cancels properly because yards and feet cancel, and you're left with only inches, and that's what the problem asks for. So now you can do math, and the answer is 36 inches. Okay, here's a silly problem to demonstrate that you don't even need to understand what the problem is about in order to use dimensional analysis. Okay, so I'm going to ask you a question. How many Nadia, excuse me, are in 2.4 Kyle. Now that's a silly problem, but if I know conversion ratios between Nadia and Kyle, I can do that. So I use 5 conversion ratios. I'm just making these up off the top of my head. So 4 Kyle equals 2 Litzy, 3 Litzy equals 5 Kenny, 8 Diana equals 2 Richie, 3 Richie equals 2 Nadia, and 1 Kenny equals 2 Diana. So now what you have to do is create 2 conversion ratios out of each of those conversion factors, and then you're going to choose which one you should put in the equation. So let's see how this works. So there you go. You start off with what you know. That's 2.4 Kyle over on the left. What you're trying to find, that's some number of Nadia over on the right. And now you're going to put conversion factors in between, and it looks like this. So let's look at this. So 2.4 Kyle times 2 Litzy over 4 Kyle. So the Kyles cancel out. Okay, and then if you look at it, the Litzy on the top and the Litzy on the bottom cancel out, because I have that relationship between Litzy and Kyle, and then I have that relationship between Kenny and Litzy. And then I have the Kennys will cancel out, because I have a relationship between Diana and Kenny. And then I have the Dianas will cancel out, because I have a relationship between Richie and Diana. And then I have Richie's will cancel out, because I have a relationship between Richie and Nadia. And the only one left at the end is Nadia. So let's see how this works. So we cancel Kyle with Kyle. We cancel Litzy with Litzy. So you notice we've lined these up in the order that makes these cancellations work nicely. Kenny with Kenny. Diana with Diana. Richie with Richie. And the only one left standing at the end is the Nadia. So Nadia is going to be the unit of measure in our final answer. So if now we can do the math. It's going to be 2.4. You multiply everything on the top. So you multiply everything on the top and divide by everything on the bottom. So it's 2.4 times 2 times 5 times 2 times 2 times 2. That's all on the top. And then divide by everything on the bottom. Divided by 4, divided by 3, divided by 1, divided by 8, divided by 3. And if you do that, it will give you an answer of 6.0 Nadia if I did the math right, and that would be your final answer. So you did that by lining up the units so that they would cancel. Once they canceled appropriately so that you ended up with only Nadia at the end, then you could go ahead and do the numbers. Okay, here's one we're going to try in class tomorrow, and it's kind of a fun one. And you might want to try it at home tonight. See if you can do it. I give you 6 conversion factors there. So the question is, Usain Bolt holds the world's record in the 100-meter dash with a time of 9.58 seconds. What was Bolt's average speed in miles per hour? So what we've got to do is we start off with, well, I'm going to let you think about this one. See if you can do it. There's the 6 conversion factors you're going to need. You're going to need all of those to do this problem. So you're going to start off, I'll tell you this much, with 100 meters per 5.8 seconds on the left, because that's what you know. And you're going to, on the right, way over on the right-hand side, you're going to need your entire width of your paper for this. You're going to need some number of miles per hour, and that's what you're trying to find. And you use those 6 conversion factors to solve this problem. So we'll do this in class tomorrow. See if you can come into class with this one done, and we'll do it then. Okay, we'll see you in class. Bye-bye.